Okay, so welcome to the lesson 2 in processing, where we're going to combine the stuff we've learned in the tutorial as well as the mathematical logic together. So at the top of the screen here, you'll see three variables being declared: Boolean, red, green, and blue. And remember, Boolean are just like clauses, meaning they can either take on true or false values. And every time it runs through, it will either assign it a true value or a false value. Next, you'll see in the setup, we've created a size of 600 by 600 and a white background. And currently in draw, there is nothing. Alright, what I'm going to do is I'm going to program some stuff and then I'll talk about it. Alright, so now what you've seen is I've programmed in three custom functions. One that's called bRed, and it makes the background red. One that's called bGreen, and it makes the background green. And one that's called bBlue, and it makes the background blue. So now what I'm going to do is inside draw is I'm going to program when it makes the background red, green, and blue. And to do that, first I want it to declare when are red, green, and blue true, and when are they false. So the first thing I'm going to do is red is going to take on the truth value of if the key pressed is R. Blue is going to be true if the key pressed is B. And green will be true if the key pressed is G. And now, if you haven't taken a look at the cheat sheet yet, just a quick, the difference between the 1 equal sign and the 2 equal signs. The 1 equal sign simply assigns the value, meaning red will be whatever this value is. The 2 equal signs is a check to see if they are equivalent, meaning is the last key the same as the character R. If this is true, so this is a Boolean statement, this will either take on true or false, and then this will be assigned to the variable red. So if the button I push on the keyboard is not R, B, or G, then all of these become false. If I push B, well then obviously the blue Boolean variable becomes true, while red and green become false. So now, still in the draw, I'm going to run if red, meaning now, what this means is, if this red here is true, then it runs whatever in this if statement. And so what I'll do is obviously, we'll just run the command br, meaning that what will end up happening is if red is true, then it runs the function bred. And of course, similarly, if blue is true, then it's going to run the background bblue. And lastly, if green is a true Boolean variable, well then it's going to make or run the bgreen function. So what you will see now is when I run this, is it starts with a white background as it's running in the setup. Now I'm going to push the R, I'll push the G, and I'll push the B. And of course I can cycle through these, and what ends up happening here is as soon as R becomes true, it runs the bred. Blue is true, it comes the bblue, and if green is true, it runs the bg green. Alright, now we're going to see why you would need some ors as well as some ands together because of the speed of processing. So imagine I said if red is true or green was true, it's going to run this. So if I push R or I push G, it's going to run the command in here. And let's just make the background, say, a random, and this time just a shade of gray. So I'm only going to put one parameter in. So if I push R or green, it's going to make it a random shade of gray. So you'll see that when I push R, it's going. Now it's not just doing one shade of gray, it's doing multiple shades of gray. The reason is because the last key that's pressed is R, and every time it runs through this draw, this statement is true. So what we're going to want to do here is we're actually going to want to say something else. So we're going to put brackets around this because we want this OR to run first. That is this true, and we're going to do the command key pressed, meaning is red or green true, as well as is there a key currently being pressed. Meaning, as soon as I push the R and release it, this part becomes false. And we know that in an AND part, both parts need to be true. Meaning, so when I run this and I push R once, we get one shade of gray. If I was to push G, another shade of gray. R. Now, you'll see that if I hold it, Because processing runs at about 1,000,000 times a second, just by holding it for a half a second, this is going to still run multiple shades of gray. So, but the speed of processing, we can't slow it down, meaning that we have to be conscious of this. So when we're doing this, this key command doesn't reset every time it runs draw. It keeps the last key variable inside it. Alright, here's a code similar to the one in the processing tutorial. So I invite you to pause the video and see if you can determine what will happen if I run this. So what's going to occur is we've declared two variables, EH and EW, as 90 and 50, which I let stand for the ellipse height and the ellipse width. The size is 600 by 600, and then every time it loops, it'll draw a white background, an ellipse that follows my mouse X and mouse Y at the center, and then the width and height as the variables above. And every time it runs through, the width is going to increase by 1, as well as the height will increase by 1. So you'll see that the ellipse will be a little taller than it is wider, and that they're both increasing by 1 pixel every time I run through. And so we've seen this in the tutorial. What we didn't see in the tutorial is what happens if we wanted to reset this. So what we have to do now is we have to run an if command. So if, let's say, and you could choose which one, I'll just do the height, ever is greater than or equal to, say, 200, it's going to run this. And what we can do is we can just reset it by declaring the variables back as they were before, so that the width and the height take back on 90 and 50. So you can see that every time it gets to this kind of tall height, that it just resets. So that is how we can run if statements as well as constant looping. Okay, so now let's also add in this ellipse height is greater than or equal to 200, maybe the statement, and mouse X is less than half the width of the screen, meaning the width of the screen is 600 pixels wide, so half of it will be less than 300. So now, if I run this, and I'm over here, what will end up happening is it obviously resets. But if I go over to the other side, is now it continues to grow. Mouse goes to the other side, immediately resets. Okay, so let's see the difference between how the and or. Let's see if we put an or here. So this says if the ellipse height is greater than or equal to 200, or the mouse X is less than half the width, it runs this. So what do you think is going to happen? Well, if I'm on this side, nothing is changing. And the reason nothing is changing is the second clause in the or, the part that says the mouse is less than half the width, is constantly true. While over here, this one will just pulsate normally, because now you can see that this part is false and that this is only true once the height gets greater than or equal to 200. So again, you can do some different things depending on which kind of and or you put inside here. Okay, so now let's look at this code. We have a variable pass, which is a simple character, which is the letter P. We have the size, 600 by 600, and we have the draw starting with redrawing the background white every time. So now let's put an if statement. Let's say the person pushes a key and it happens to be the same as pass. And just like before, I'm going to put the key pressed in such that every time it loops, it checks that whether the key is actually being pressed and not just if the key is the last key that's been pressed and released. And so we'll put text in. So remember text size first. I'll put 32. Then we'll put fill and we'll make the text red. And now I'm going to put text in as the simple thing, you got it, meaning you found the password. And we'll put that in about 50 across and say 100 down. So, and the last thing, obviously, we got to close off the squirrely bracket for the if. And let's run this. So now, if I push P and hold it, it says you got it. I'm going to let go of P right now. So the moment I do that, you'll notice, is the thing you got it goes away. And the reason is background is redrawing over this. So if we don't want that to happen, is what we can do is we can actually just put the background in here. So that means every time it redraws it, it'll immediately run you got it. However, if I release the key, it doesn't redraw the background. So just a little bit of change, you'll see that I'm going to push P, and it says you got it, but now I release P, nothing happens. So what we're going to do now is, what we want it though, is what happens if they push a different key. Now you could put if key is equal to A, if key is equal or B or C or D, and of course that would get very, very, very redundant. So instead what I'm going to do is say not equal to pass, meaning the exclamation mark says if key is not the same as the letter pass and the key is pressed, what do you want us to do? Well, of course, we want it to run the exact same code again, and we're going to change it just a little bit, is instead of you got it, maybe wrong, try again. So when I run this, is I push P, and of course it says you got it, but if I push W, Q, anything else, P again, you got it, M, P, H, P, S. And since you can see now, because we have the background here as well as here, the you got it and the wrong try again disappears as soon as we type in the right one. Now the reason we like using variables is, let's say someone found out the secret password. Well, then I can just go up here and change it to Q. Now when I run it again, and as soon as I push Q, it says you got it. X doesn't, and I hit P now and it still says wrong try again. Now of course, if we notice is that if we didn't use variables, I would have to find every place where we use the pass thing and change it from P to Q. So variables help us out quite a bit in quickly changing code. Okay, so I've covered quite a bit. Again, please check the reference, please watch the processing tutorial, and please try to create something very creative and innovative using this programming, processing, as well as logic.